Okay, we are still doing the disk method for volume by rotations. And here we've got a description. We don't have a graph. So it says rotate the region contained by x equals the square root of 5, and then x, y squared. Then the other line, x equals 0, and between y equals -1 and y equals 1. And we're going to do that around the y-axis. So let's draw ourselves a little picture here. We need ourselves a graph. I mean, we can find it elsewhere, but let's try and draw one to start with. So the region that they give us here is going to be between y of 1 and y of -1, and whatever we create, we're going to take around the y-axis. Now it says we're going to graph x equals the square root of x y squared. So let's see, what does that look like? Well, it's a parabola on its side. And if you take it, you know that if you plug 0 in for y, you get 0 for x. But let's take these 2 points here. Y of 1 would give me square root of 5. So let's come out here to square root of 5. So I have this up here. And y of -1 would give me positive square root of 5 as well. So it looks like a parabola on its side, like this. But it's very important that you get the right region here. So it says we want this region from 1 to -1 for y between there and the x-axis. So here's the x-axis over here. So we're really taking this little region that I'm shading in. It looks kind of like a sideways bowl, but not the bowl, the part below the bowl. Now we're going to rotate that around the y-axis. So the figure will look kind of 3D. I can't draw it. But from a cross section, it will look similar to what I have here. So since we're going around the y-axis, we want to write it in terms of y. So we'll have the integral of in terms of y, and that y is going to run from -1 to +1. And it'll be pi. I'm just going to go ahead and put the pi on the outside. Now, we got to get the radius here, and the radius is coming from the axis of rotation, which is the y-axis, out to the curve. And that curve was x equals square root of 5y squared. So we want it in terms of y, so it's already there. So that radius will be square root of 5y squared. So it's going to be a radius squared, and that's going to be dy. Okay, so everything is in terms of y. So there's these little stacks of disk on top of each other. Okay, going all the way up and all the way down in here. So just kind of picture that. So let's do the manipulation, and then we'll do the integration. So we got the pi out front, running from -1 to 1, and we're going to square this thing. So if we square square root of 5, we get 5. And if we square y squared, we get y to the 4th. Now we haven't integrated, so let's do that now. So the pi out front, and it will be, if we integrate 5y to the 4th using the reverse power rule, I think we just get y to the 5th. So we get pi y to the 5th, and that's going to run from -1 to 1. So let y equal 1 will give me pi times 1 to the 5th, which is 1. And then I'm going to subtract. Let y equal -1. So that would be subtract pi, and -1 to the 5th is a -1 as well. So I'll have pi times 1, which is pi, and then minus a negative pi, so it'll be plus pi. So the total area, the total volume is 2 pi. Now that's not a geometric shape that we could really work with because it's curved there. It's not a cone because it's curved in. Okay. Notice that we couldn't go around the x-axis of what we know because it wouldn't be disk. We don't want the middle part here. But let's see what our next problem is. Rotate the region contained by y equals x cubed, y equals 0, and x equals 2 around the x-axis, and find the volume. So let's draw ourselves another picture. So I'm going to give myself a XY grid. maybe not the best here. But what do I want? I want x equals 2, which is out here. And I want y equals 0, which is the bottom part. And I'm going to go around the x-axis so I have my region. So y equals x cubed. That means plug 0 in for x, you get 0 out for y. You plug 1 in for x, you get 1 out for y. You plug 2 in for x, you get 8 out for y. So the curve looks something like this on the positive side. Now we're going around the x-axis. So I think I'm just going to forget about the left side, other side over here. Know that it looks something like this, what the cube does. But let's see here. X equals 2 is over here, up to the curve. So really slanted, and the x-axis, yes. So I've got the area under the curve of x cubed all the way out to 2, but I'm going to rotate that around the axis, so I'll have something that looks like another kind of curved cone or pyramid on its side. So keep in mind that that's supposed to look like a point. There's a circular region there. So not quite a cone because it curves in. But let's see if we can make the integration. So pi, and we need some endpoints, and because we're going around the x-axis, let's do it in dx. So the endpoints for x would be 0 to 2. And then the radius would be from the axis of rotation out to the curve, which that curve was y equals x cubed. So we're pretty happy that it's already in terms of x since we want dx. So we'll have x cubed as the radius, and then that will be squared. So pi from 0 to 2 of x cubed squared dx. So let's see here. We need to clean that up first. So pi from 0 to 2 of x to the 6 dx. That'll be pi of 1/7 x to the 7th when we reverse the power rule from 0 to 2. So let's evaluate. We'll let x equal 2. So that will give me pi times 1/7 times 2 to the 7th. And we'll have to pull out a calculator in a moment. Minus, let x equal 0. So that is 0 if you plug it in. Now it's not a good idea to always just assume everything is 0 because it's not, depending on what's over there. But let's see here. We've got 1/7 pi, so pi over 7, and then 2 to the 7th. 2 to the 5th, that's 128. So it looks like this should be 128 over 7 times pi. Okay. And just be careful. Take your time. A graph really helps, whether you get it from software or you create it yourself. So it's very nice to be able to graph these. I wish I could draw three-dimensional shapes better.